Um, the water part of everything is huge. And so I'd like Kevin to talk just a little bit, give an update on what he's doing with the water equipment. You all are familiar with that, but I'd like him to give a little update before we get started here.
Thank you. Thanks everyone for being here. We appreciate it. I'm going to go over just a little bit about the water equipment and more about what's really happening with New Force Water. Most of you have our equipment, and what it's doing is we hydrate plants. That's why we, in our name, I don't have my banner up, but it's New Force Water Technologies or hydration technology. It's all about hydrating. So you get into the soil, into the plants, into the leaves, into the animals, and into yourself with water that's actually good to drink. As a matter of fact, we're doing the same thing that the Lord does in streams, creeks, and waterfalls, spinning and twirling in sunlight. And He made it so you can hydrate. Man comes along and gives us all kinds of chemicals and chlorine and bleach and salt and RO. You don't need this stuff. You need to hydrate. So, having said that, we have different models for different reasons. Now I'm a little on the kind of bragging side, we're breaking into a lot of dairies now. It's really picking up. Animals can hydrate. They can handle the heat and the cold much better. They produce more milk, and we have people that's got them in, and we're doing quite well with that. Also, we've been very blessed to have a couple of state representatives like what we're doing to put their arms around us. And Vernon and I have met with them, but now we have a total of 5 that we have to meet with, including the Secretary of Ag. That's a big deal. Because one of the issues that I was having is cancer rates. And cancer in Iowa is the highest in the United States. And then Sioux County and Lyon County are number 1 and 2 in the state of Iowa. And I think most of you know we've had quite a few people passing away because of the cancer. So we are going to help work with trying to find ways of controlling the nitrates in the soil, changing stuff in the water so we can get rid of or reduce nitrate levels in the water. So we've been very blessed with the things that are going on. Also, distributorship has picked up really huge. We're now up to 51 distributors in the United States in 33 counties, 33 states. And I just got a call from Canada. A young organic farmer up there said, that's it. He says, I want to start doing things different than the way everybody else is doing it. And that's what's going on with us down here. We have to change the way we're doing farming. We have to change everything about farming and even diversifying into different types of crops. I mean, those subjects have been on tons of legislation, people in counties all over. The organic world is really coming up. And even with conventional farming like we're doing, with the products, with Verlin's got, with the biominim and stuff, it's really making a huge difference and it works. And a lot of you already know that, and that's why you're here again. But I want to thank you for all the individuals that helped me get started. It's been pretty rough, but we made it. So I'll turn this over to Verlin, and thank you again.
Thank you, Kevin. So we brought these plants today. I lost sound. What'd you do?
There you are.
Okay, there we go. So we brought these plants today. This is not typical of what our products do. I just want you to know that up front. And this is a little experiment that we'll get into a little later here, but Jake Lamplot is here. He ran this experiment, and so he'll explain all this. So I don't want to get started on the wrong foot and think have you think this is the way your stuff's going to look. So anyway, that's really some interesting stuff that pertains to what we're doing here. So anyway, what we are dedicated as a company to do is to reduce producer inputs by 50%. And we have a few producers that are headed down that road and have done some of that and are not experiencing yield reductions from what we're seeing. And I could give you a lot of examples, but we're not going to do that. We're going to try and stick to the facts here today, because I want to go through R&D, the information we've collected this past year on a number of different things. And then at the end of the program here, we'll hand out what our products are going to run this year, and also a recommended sheet on recommendations on how we recommend it. It's a very simple program, and you'll find that out. So this is, when you talk about balance, symbiotic relationship with Mother Nature, and the key to profitable production. I don't have to tell you what input costs have done. You know that. And I think some of the things we've done in agriculture to stay profitable so we can, so you guys can keep operating is all related to input costs. And as you know, they've gotten out of line. And so a lot of producers are looking for answers. And just so you know, when you talk about fertilizer, last Friday, I was asked to put on a presentation out in Illinois for a seed company out there. And there was one of the presenters there, a PhD in entomology. And he talks about sugar and sugar content in the plant and how that affects predators and disease and all that. And we'll talk a little bit more about that as we go along. But here's the thing that you need to be aware of. He was asked to come and meet with Nutrient Ag. You've all seen Nutrient Ag all around the country, right? They're probably one of the largest fertilizer distributors in the US. They had this guy come up a day ahead of the meeting that he spoke at, the same meeting I spoke at. And he told us this at the meeting. He met with the head guy because they are concerned that the regulations coming down on fertilizer are going to be drastically reduced on what you guys can put on. And they're not sure what to do or what direction to go because this is their business. And they're huge. And they are worried to death. Clint was at a large co-op in his area. They've got, looks like around 70 locations, roughly, in Nebraska, Iowa, and Kansas. And they know that he's doing something different out there. And Clint, you want to explain briefly what they cornered you on?
So I went in yesterday to basically pin down my bean price for seed. I last minute type of shopping guy. And when I walked into my salesman office yesterday, another guy followed in right behind me and shut the door. And I was like, what's going on? I was very uncomfortable. And they started asking me about all my biology and stuff like that. The guy I buy seed from, he scouted my fields last year. We had a lot of rust. I didn't use fungicide until the very end of the season, the last Monday of August. He'd been in those fields. And I know he's been in a lot of fields around the area. And evidently he saw something different in my fields than the neighbors. And they want to sit down and talk and see, because they know biology is going to be the next thing, but they're having troubles finding stuff that does something. And they need to have returns and something that's cost affordable. And so basically, I'm waiting for a phone call back from the higher ups. So that guy was one of the head sales managers of the area. So I was nervous the whole time. I didn't know what was going on. But now that I know, and hearing what he just said about nutrient, the these guys find out about these restrictions coming down well before us public guys know. They've got inside connections, so we know this stuff is coming. It's best to be prepared, find a system that works. This is what I use on my farm. I'm banking on it 100% this year. I did it last year, and yeah, we got results, and they're there. It happens. It works.
Okay, so what we're gonna present today and what we'll show with this little demonstration up here is how you can get more out of what you have out there, whether you're putting manure on, fertilizer, can you cut back, all of that type of thing. So, we'll get moving here. Maybe, oops, wrong button, okay. All right, so this is, the reason I put this slide up here, because this is what it's all about. Hang on here. All right. Biological agronomy, the adaptive soil management system used to build soil microbiology through intensive regenerative practices. That name gets used all the time, regenerative. That increases carbon and nutrient ability for profitable crop production. And you cannot, the problem we're having in agriculture today is the moron theory. We're moron. And that's not working, as you all know. Especially with nitrogen. There's a lot connected to that, but carbon is key in all of that. The higher you get your carbon levels in the soil, it's a proven fact, the lower your nitrogen needs. Okay? And that's what we work on biologically. So, we're going to start with nitrogen, as we just mentioned. So, 78% of the atmosphere is nitrogen. How many of you put nitrogen on? Everybody does, right? You have to. The plant has to have nitrogen. Where does that nitrogen come from that you're putting on out there, whether it's 28, anhydrous, AMS?
Natural gas.
What was that?
Natural gas.
Natural gas. So what they do, 78% of the atmosphere is nitrogen. So what they do is they pull the nitrogen out of the air, they combine it with natural gas, and under heat and pressure, they get NH3, ammonia, IA, ammonia. What is ammonia? Anybody know? Anhydrous, they call it anhydrous ammonium. From ammonia, they will take the ammonia and they will combine it with nitric acid and sulfuric acid. When they combine it with sulfuric acid, you get AMS. When you combine it with nitric acid, you get another product. And, excuse me, not nitric, phosphoric acid, So they take ammonia, combine it with phosphoric acid, and you get MAP and DAP. Okay? So that's where your nitrogen comes from. You got all this right above you, and you're not utilizing it. The plant can't utilize it in that form, as you well know. Otherwise, you wouldn't have to put any on, right? But it's very simple. Okay. So we all know that nitrogen is highly mobile, and through all the testing they've done, only 10 to 40% is taken up by the plants. The rest goes where? This way and this way. And down the Mississippi and into the Gulf. And I'm telling you one thing right now, there are groups in Iowa that have the target on Iowa because of all the pollution going into the rivers and streams. I forget how many thousands of tons of nitrogen goes down the river every year. And like Kevin said, the Ag Committee in Iowa has asked to talk to us because one of the representatives that Kevin works with has told him what we're doing. And we would have had a meeting with him ready, but I haven't had time to get down there because of our schedule this month. But they are dead serious about this. And they've already done this in Wisconsin. They've elected Democratic governor and a state ag guy, same guy that NAG would be in Iowa. And they have gotten resolutions in there that has restricted how farmers can use nutrients. And that's their target for Iowa too. What Kevin didn't tell you is the governor has appointed a young guy that we're working with to tackle this as well. And I'll show you, we'll get to that, and we've covered some of this before, but I'll get to that on what that means. So there's no way you can bank nitrogen, is there? Yes, there is. We'll talk about that. All right, this was, one of the guys here did this test, since we're talking about nitrogen. He did a preseason nitrogen test, and I'm gonna pick on you, James.
I was I did the test in fall and then I did it at B5 also.
Okay, in fall at B5, and what'd you find?
The fall test said I needed 170 pounds based off of expected mineralization and nitrates in soil and yield. And in season, it told me I had enough there for 270 and I only applied 90. So the yield was exactly the same, where I applied more and than where I didn't apply anymore.
He called me up and he said, this is what my test shows. What do I do? So he had 90 pounds you had applied, right? And the yield said you had enough there for 275, right?
Mhm.
I said to him, so that you can sleep at night, why don't you just go to 125 and then see what happens? So what he found out was the yield was the same where he had 90 and 125. How many of you have reduced nitrogen inputs? Okay, good. If you're not, you need to play with it because you're going to get forced into it one way or the other. You'll find out. This came from one of our distributors. Just want to show you this guy. He's a 270, 300 bushel corn grower in Nebraska. He's got irrigation. So what he did was he had the ABC and furrow first year with us, and then several passes of Biomentum as well. So this is what he put on for nitrogen, 134 pounds, and he got 275. He had a nitrogen use efficiency of 0.48. How many of you are still going on the old numbers of 1 unit of nitrogen to 1 bushel of corn? A lot of people are, okay? Our distributor worked with him on this, so he also put on 2 gallons of amino N and a fungicide late. Now, this could enter into some of these yields as you look at this. It could be skewed a little bit. I wish he hadn't done that, but he had tar spot or southern rust, and so he had to do something. So the next one, plot was 134. He had 282. He was at 0.47 nutrient use efficiency, and he put this on over the top as well. The next one, 155, 248, 0.62 use efficiency, 166, 269, 0.61, 189, 0.68 nutrient efficiency, 230 pounds of nitrogen, 246.93. No aminos or no fungicide. So again, that might have skewed things. This might be more realistic number here since this was treated all the same as the other, but fungicides definitely paid off this year. And so we're not trying to any wool over anybody's eyes, but, this guy, this coming year is gonna do things completely different than what he's been doing. If you don't do a test like this on your own farm, you're missing the boat, okay? I know nitrogen is cheap, but, it's not that cheap. Okay, so this is what happens. You guys have got billions of nitrogen fixing bacteria in your soil. They're there. They're available to use, but they're not available when you start increasing nitrogen. When you get above 90 units of nitrogen, those things start going to sleep, okay? When you get up to 200 units, and this gives you the mean total bacterial fungal biomass. So what's happened is those things stop working for you. They're free out there. They stop working. Do bacteria and fungi release nitrogen? And what is the C/M ratio of bacteria and fungal? And yes, they hold nitrogen. They also hold NPK, sulfur, all of those nutrients as well. So how many of you know what the C/M ratio is of your soil? Anybody check it ever?
Yeah.
Some of you do. Okay. We're gonna back up here a minute. So C/N ratio, why is that important? So you've got all kinds of bacteria in your soil, billions of them. The problem is you've got 90% bacterial and 10% fungal. Used to be 50-50. The fungal is what carries 90% of the nutrients into the plant that you're always short of. So what happens in the soil is in every 1% organic matter, you've got 10,000 pounds of carbon out there. The problem is it's not in an available form to the biology because 50% of your organic matter is carbon. The other 50% is dead microbes with all the nutrients in it. If you have things working really well in your soil, you'll get 3 to 5% of that carbon and the nutrients in that organic matter out in a year's time. You're not gonna mine your organic matter. Here's the problem. The available carbon is not there. The carbon to nitrogen ratio in just about everybody's soil is 8 or 10 to 1. Do you agree, Russ?
Sure.
If you do the Haney test, you'll find that out, okay? Biology is just sitting there doing nothing in your soil at 8 and 10 to 1. That's only enough carbon to keep it alive. Not to make it grow, not to have it do anything. Not until it gets to 16 to 1 do you start getting reproduction and getting that whole system working. 16 to 1. I would encourage you to do a carbon to nitrogen ratio on your soil. When you get to 24 to 1, things are really humming. I've got a customer in Ohio, he's been with me for a long time, and he's started picking up the amount of biology. He's been increasing the amount of biomentum that he's been using. He's at a 16 to 1 carbon to nitrogen ratio. He raised 200 bushel of corn last year and he's happier than a pet coon because the only thing he used was about 20 gallons of 28, some trace minerals, some ABC and furrow, and some biomentum. Said I can make money all day long with those kind of inputs. And believe it or not, his P1 in his soil is 4 to 5. Where's that coming from?
45 or 45?
4 to 5. 4 to 5 units of P1. Okay?
You guys also have to remember, Ohio, they're happy if they get 150 bushel corn, that's excellent. So they get 200 bushel of corn is off the charts.
Yeah. they got some tough soils out there. Okay, so what's in the Biomentum, just to remind you, and of course, this is the Biomentum here. The Biomentum is 25% fungal, 25% nitrogen fixing bacteria, and the rest is bacterial, colonies that do all kinds of things. All right, so the problem we're having is keeping these things alive, and the biggest thing, like I said, is fungal. So how are we gonna do that? Well, how many of you have used glyphosate or glufosinate? Anybody here has? I think just about everybody has. So the problem with, while it's terrific on weeds, the problem is it reduces fungal numbers to almost zero. Any of you know what glyphosate was originally used for?
Cleaner.
Cleaner. They used it to clean boilers, right, Howard? They used it to clean boilers. It would pick up calcium and all those other nutrients and it'd clean them up slick as a whistle. And it does the same thing in your soil. And that's the bad part. So this is the rest of that. These are, and that slide is in there. We're gonna touch on all these and what we're doing biologically with all these different things here. So this is just a quick slide. I like to show this. But glyphosate is toxic to mycorrhiza, nitrogen fixing microbes, which you guys have free of charge in your soil, biological controls, earthworms and all that. And it ties up all these important nutrients. How many of you do tissue samples? I encourage guys to do that because a soil test shows you what's in the soil. It doesn't show you what's getting into the plant. What good is a soil test if you keep pouring nutrients out there every year and you don't know what's getting into your crops? Why are you only getting 230, 250 corn? I had put a meeting on for a distributor up in Minnesota on Tuesday. One of the guys there used to sell Conklin. And he said, you know, we had a guy, this was 20 years ago. He said, I had a guy, all we did was we put zinc in with his fertilizer and he picked up 40 bushel an acre on corn. Now he understood, you know, why that all happened, but you can keep pouring all these nutrients out there, but if you don't know what you're short on, and if you want to be efficient, and it only costs a few dollars to put that nutrient you're short on in there, and you can have an influence on your yield for very little money. So that's why I'm not picking on Roundup, but there's a good side and a bad side to it. This is the bad side, and you have to realize that this can be limiting your yield. What's the half-life on Roundup?
20 depends on the soil, 22.5 years, so it's
Up to 22 and a half years. Up to 22 and a half years. So if you put a cord on 22 years ago, half of it's still there. And that half is tying these nutrients up that you're always short on your leaf analysis. Okay, just trying to explain what's going on out there. Farmers are frustrated because they can't get past where they want to go. Okay, so you either have to deal with this and put these on, or you need to be able to break the glyphosate down so that these then become available. Glyphosate's a strong chelator. Okay, some of you have seen this before, but this was a test we did in hog building a number of years ago, where one building we treated with the pucks for 6 months and the other we didn't. The glyphosate in there was 131 parts per billion, per billion, and the one we treated was 67.5. And we were told at the time that may not be accurate. This was when they first started checking for glyphosate. But if we can reduce that number by half, we can help this right here. Okay, then the next slide in there, and I'd like you to pull that out of your sheets, if you would, please.
Ferlin,
Yes.
if you apply Biomentum in the tank with glyphosate, will it prevent glyphosate from working properly?
No, it will not prevent glyphosate from working properly. It takes longer than that to break it down, okay? It's not, you're not gonna put it in with it and it's just gonna make it ineffective. We got lots of guys putting the two together, okay? But I'd like you to pull this sheet out because this is important. You see, I have an individual here who wanted to test a product that breaks down glyphosate. And so he asked if there was someplace we could do that. He talked to another producer that is here today whose farm we did this on. And as you can see, the results up here on the top where we did nothing, number one, the level of glyphosate was at 130. Okay, nanograms per, whatever, I can't read that. You can see it on your sheets. But anyway, where we put the ABC in furrow at 3 quarts, the regular rate, we dropped that down to 40. In 6 months, dropped it down to 40. The next 3, 4, 5, and 6 were the product that the individual wanted tested. And they all had 3 quarts of ABC with it, and you can see the numbers and what happened there. So if we can break down the glyphosate in the soil, because it's not doing you any good anymore anyway, once it's there. If we can break that down and make those nutrients available, you're gonna have an edge, okay? There's additional sheets behind that sheet you just pulled out that you might want to read. It's about some information that's been done. As you know, glyphosate's been targeted for a long time now with many lawsuits, and it's highly suspect in cancer rates. And again, I'm not picking on glyphosate, but I'm just saying, if you're interested in that kind of thing, that's some pretty eye-opening information, okay? All right, so are you leaving fertilizer dollars on the table? We've talked about this before, but this is, I just want to bring this out because we've got a number of guys that use the biology in the pucks on manure. And so is it doing the same thing in manures in soil? This is the puck label here. This is I'm gonna pick on John, he's here. But he had the building in 2022. He did the analysis on the nitrogen there at that time was 54.5, and all the other nutrients are listed there. After he put a double rate in, but it went from 54 to what did it go to? 83.6 on nitrogen, and just about all the other nutrients doubled. And this was year 1. This was year 2. And this was year 1, and this was year 2, and the numbers come out pretty close to the same second year. So again, 85% of the nutrients plants take up are microbial mediator. So what was the ROI? You guys if you're not mindful of our ROI, you're not gonna be farming very long. So this is a sheet that shows what the difference was. You put $3.60 in, 1,000 per 1,000 gallons of manure with pucks, and this is what he got back in NPK. the values all went up 54 to 83, 15 on phosphorus to 37, 28 to 45. Where'd that come from? First of all, in case you're not aware of it, glyphosate goes into the terminal bud of any crop, and that includes corn and soybeans. So it's going to have the same effect in the grain in tying up the nutrients as what it does in the soil. It's natural. It's just, that's what's going to happen, okay? So biologically, what we're doing here is we're breaking down the nutrients in the grain to make things available. And I threw the zinc one down in here on the bottom just because you can do the numbers on all these if you really want to get it. But $40 is not really real. It's probably closer to 60 or 80 that he actually picked up on there, but I didn't take the time to do that.
So you're breaking down the glyphosate, where is it going?
So when glyphosate gets broken down, biologically, it gets broken down into a simpler form. Say that louder, please.
Carbon, nitrogen, and phosphorus.
Okay. It's no longer a factor.
Is it fertilizer then?
It's fertilizer. Yeah. Absolutely.
Why not put it in feed?
Yeah.
Make it more efficient to begin with.
Yeah. That's a good idea. I've done that for years, but I just don't push it. I don't have time. But yeah, it's effective that way as well. One of the guys that's not here, he's doing doing a trial with that on hog buildings. And he's using a humate source and the biomentum. Okay, he started with the humate. He's got the numbers on that, and now I put the biomentum with it. And so I've done this the last 15, 20 years, and we reduce death rate, improve feed efficiency, and all that, just like you said. But I don't have time to do that. So that's kept.
About glyphosate in the hog bits, where it reduced it by approximately 50% over a term.
Yeah. Yeah.
That's a big deal.
Well, it is it should be, if you're a farmer out there. So how many of you have had gassing? Those of you that have, well, I'm not gonna pick on anybody. So you've heard of hog buildings exploding, right? That's methane gas. And we've had a hard time getting the biology unless we pour enough in there. And that doesn't even help altogether. We've had a hard time getting that, just the biology to take care of that methane. Here's the thing with biology. You guys have all seen this before. This is a bacteria. 5 carbon, 1 nitrogen. 1 nitrogen. It's in your soil too. It's land. 5 carbon, 1 nitrogen. What we're trying to do is we're trying to increase these guys 5-fold. Fungal has 20 to 25 carbon to 1 nitrogen. But here's the thing. When you put biology in a hog pit, down there at the bottom where the problem is, it's anaerobic. And most biologies cannot live in anaerobic conditions. The biology in the biomentum is facultative. It lives in both oxygen environment, aerobic and anaerobic conditions. So when you put that in there, it's going to start to work. The problem is, just like in the soil, there's not enough available carbon. These black balls, not enough available carbon. So what we've done is we've put carbon with the pucks just like we do with the ABC. That's been the basis of our program. We have amino acids, biology, and carbon. When you put the carbon with the biology, you get an available source of carbon and you start this process and you get these numbers way up. And I'll show you in just a little bit. But carbon is extremely important, whether it's in a hog pit or whether it's out there in your soil, to get the right biology going. Okay, any more questions or comments?
How much carbon is in Fulton compared to humic?
So the humic acid is a much larger molecule. And you can't really say how much more carbon. Yeah, I guess that is a good way to put it, but there's 10 times more sites on a fulvic molecule that is about 3 to 4 times smaller than a humic molecule to hold on to nutrients. And of course, it's food for the biology, but it has a lot more sites, so it's more reactive. It's much smaller though, so you can get it into the plant. So foliar wise, it's what you want to use.
What about in soil?
Same way. We'll get to that in a little bit here, but we've got a product called particle foliar, and I'll explain that a little bit more. Okay. Okay. So this is a guy. I don't know if you guys have seen this before now, but this producer up there by Brookie, and he's got grass hay and he's got pasture because he raises beef. He raises organic beef. So what he did 3 years ago, he started putting biomentum on at 8 ounces per acre. And what he found out on his grass hay, from years of cutting the same brome hay, he increased his yield by 33% the first year, 45% the second year. And so he is extremely happy. Now, what he also did on his pastures was, since we're talking about nutrient uptake, is he sprayed, he has like 6 pastures out there. He sprayed the biomentum on some of them, but not all of them. And what he found out was his mineral intake at 8 to 16 ounces per year, per acre, that's all he put on, that his mineral uptake by his cows went from almost 3 ounces per head per day down to under an ounce. And he said to me it's closer to a ½ ounce when they hit the pastures that had the biomentum on them. Simply because he was getting more nutrients out of the grass, so they weren't going over to the mineral feeder to make up for what they weren't getting before. Extremely happy with what's happening. Okay, I've shown this slide before, but I'm showing this again just to make a point here. So there's corn here. This is a field down in Georgia, which many of you have seen. But this is a cornfield, and that's giant amaranth pigweed, which they cannot kill with Roundup. So the only difference between this half of the field and this half of the field was and you can see down here in the bottom, that there was a few of them that got missed, but yeah, there's some grass out there, but that's easy for those guys to kill. And granted, this isn't that good looking cornfield, but it's pretty good looking down there. Anyway, there's no pigweed out there. The only difference is the calcium. We put on, what did we put on? 1,800 pounds, 500 pounds of Pell lime out there. And where'd the amaranth pigweed go? It's not there. Why isn't it there? Because of nutrients. Very simple. Guys that have been using the program for 3, 4, 5 years at the right rate all tell us they're seeing a decrease in weed pressure. So then, this is the same guy. Over the last 3 years, I tested biomentum on a 68-acre pasture. Changed the way I look at weeds. I used the step process. In year 1, I used the full amount of 2,4-D and only 8 ounces of biomentum. Year two, I cut the herbicide in half, and put 8 ounces on. Year three, I did not use any herbicide, just 8 ounces biomental. I cut out the herbicide and it worked. I saw a decrease in weeds every year, specifically Canadian and bull thistle. In the third year, I've almost completely eliminated bull thistle without a drop of herbicide. So what's happening out there, and this is the reason I showed the other one first, with the amaranth pigweeds, is it comes down to this. When you get the book, When Weeds Talk, the first column that indicates why a weed is there is calcium. And over 90% of the weeds are either low or very low on calcium. Now, your soil test says you've got lots of calcium out there, but it's not in an available form. That's the problem. And so biologically, what we're doing is we're making that calcium available. That's what happened in his pasture. That's what happened in that other field down in Georgia. Available calcium. And when you get that calcium that you've got tons of out there, freed up biologically, then you'll see some of these things go away. Okay? Keep working, keep it going. Orthooptics. We've talked about this before. We introduced those guys to our program here last year, and we had these guys give a couple talks. The guy that gave a talk here in December presented some of this information. It's a management tool for those of you who are not aware of it, and it has some very good, I think, some very good reasons to use it. So this is what they measure: the physical, soil productivity, the chemical, nutrient availability, and the biologicals, pests and pathogens, biofertility, soil organic carbon, and all that. The physical is a compaction. Okay, this is an example of what their stuff looks like. Compaction called True Till. How many of you guys own one of these? And I always ask this at every meeting. Okay, you know what it is? It's a soil compaction tester. Is there anybody here that doesn't have compaction? Compaction is the number one problem in agriculture today. It's the reason you have all these predators in the soil, because if you had the aerobic biological activity going out there, you wouldn't have half of these predators. So compaction is the number one issue. And that's why I'm throwing that in here. And this is the nutrient side, and this is the true bio, the biological side that they do. This is what they measure below ground, corn rootworm, and all of these. Fusarium is a big one. How many of you have dealt with any of these or know that you have? Has your agronomist come out and said, you've got SCN in your soybeans, or SDS, or Fusarium, or Rhizoctone, or Pythium? That's what we're trying to measure. And then, of course, biofertility, nitrogen fixation, and all that. So, this is a trial that the guy did. He kind of laughed at us last year, but he's not laughing anymore. He did on dryland corn, irrigated, dryland rotated, and dryland corn, corn on corn here. This was the ABC starter versus their standard grower. And they increased about 9.4% yield with ABC starter, about 21 bushel. He was really happy with that. But here's the other side of it. 17.4% increase in nitrogen fixation potential. Urease improved, sulfur solubilization, root colonization potential, gram positive, gram negative. Fusarium was reduced by 80% in fields, gibberella and stock rot by 90%, and tar spot by 80%. Now, that's as big a deal as what bushels per acre are. Because of this. If you're not aware of it, crown stock rot is getting to one of the biggest problems in corn production today. And the reason it is because fusarium is the main culprit in that. And if we look at this, you see what happened with this fusarium, 80% reduction. But fusarium comes in because we're planting corn earlier and earlier. And when we have cold, wet conditions and plant early, that's when fusarium starts. You don't even see it. You don't see it until harvest time. That's when you see the devastation of what happens to it. But fusarium is a big deal.
Verlin, you might add an SDS in soybeans derived from fusarium.
Oh, would you repeat that, James?
SDS in soybeans is derived from fusarium also.
Okay. So these soil organisms, we're having bigger problems with them every year. But if we can start to eliminate those biologically, that's going to make all the difference. This is just a trial they did with fungicides. And as you can see, where the fungicide, of course, no ABC and ABC, but where they put the fungicides on this year definitely paid. Okay, this sheet is in your packet. And I'd like you to dig it out because there's one thing on here that is extremely important. These are all important and you can look at those later, but tar spot is on there. This is just a breakdown of what this guy tested with the ABC versus no ABC, as you can tell up there. But down here, cytophore production. Anybody know what cytophore production is? Clint does. That's because he knows. Cytophore production is the release of iron in the soil. I had a distributor call me yesterday, and they're going to try out a product that actually reduces the iron in the soil. You need iron. I've got a tote of iron back at the shop. If you want to green up grass really fast, you spray a little iron on it. Why? Because iron is a central molecule in chlorophyll production. Without chlorophyll, you don't get sugar. Without sugar, your plant stops. So this guy was all excited because they've not been able to find, no, I'm going the wrong one here. There we go. Because cytophore, they've not been able to find anything in all their testing that releases nitrogen. So that's a big deal, and that's another advantage of the biology. So this sheet you have in there also, and if you pull that out, please. Hopefully you can see it. If you can't read it, you're gonna have to read it. Yeah, okay. Well, okay, what this points out is the biology was put on at 16 ounces of B3. The uptake of nutrients without it is much lower than with it. The chlorophyll numbers were higher at B9. These are B9 numbers, as well as the sugar. And that's what your whole production system is based on. How much sugar you can get those plants to produce. And what happens if you don't. So we're talking about increasing fungal activity, and that's the root of our program. So Dr. Elaine Ingham got kicked out of the university limelight over 20 years ago because she was saying we're killing the good biology in our soil by what we're doing. She kind of forged the way for all the biological stuff going on today. But this is symptoms of a fungal deficiency. How many of you have adequate phosphorus uptake in your plants? If you do a tissue test, you'll know. Okay, the big guys that grow the 400 or 500 bushel corn say you need at least 0.35 and 0.55 is better for phosphorus in a leaf analysis sample if you're gonna get good yields. Phosphorus is one of the limiting factors. So what we're talking about here is phosphate and zinc are immobile ions in the soil and determined by root structure. What the microhydrofungal fungal does, it extends that root system by up to 100 times if you can get it to grow. The problem with phosphorus when we put it in furrow is it stops the growth or prevents the growth or hooking up of microhydrofungi with the root. So when you put phosphorus in furrow, that hookup doesn't happen because the plant senses there's phosphorus there. And then when it runs out of phosphorus, it's starving for phosphorus. And usually at a critical time when the plant's making decisions. So be careful with that. Again, the big guys say don't put phosphorus in soil. That's not coming from me, that's coming from them. So when you get that hookup, however, microhydrofungi can go out and pick up all the nutrients that the plant needs. By the way, microhydrofungi has the ability to latch onto a rock and pull the minerals out of it through the exudates and the acids that it can exude to make that happen. The big thing here, right down here, is increasing soil diseases. Beneficial fungi include species of fungal which devour pathogens. When the good guys decline, the disease level increases. Everybody's seeing disease levels increasing on their plants. And it's going to continue to be a bigger problem. So that's why we're trying to grow more fungal in the soil. We mentioned this. These are the ones that are listed on up above what we just covered. This is just a synopsis of a field, some fields that we did. There's 5 different fields here, and it shows the different things. There's corn, and it shows fusarium, lithium, anthracnose, rootworm, for those of you who are interested in rootworm. And when it's red, it's not good. When it's down here at the bottom, that's what you want to see. But we're not, this is the first year we ran this trial in Nebraska. So we'll have to see how it goes from here. But this one is on corn, and there's 3 different things here, 3 different levels looked at here on corn. And then on soybeans, we have another group here that shows the different diseases. And I included those in there just for you to look at. We're not gonna delve into those right now. If you're interested in that type of thing, you can. So what I would like to do is I would like to have Jake Landblad come up here. And I would like him to explain what's going on with these plants up here. Jake is very resourceful person and has, you can go ahead and switch your slides up there as we get up. These numbers in here, we included in here. This is kind of a synopsis of the readings he's going to talk about. And as you can see, it lists pH, Briggs chlorophyll, conductivity, nitrogen, phosphorus, potassium, calcium, all of that in there. So iron, again, as you can see, the iron in the Biomentum pot, if you just remember, that was 6.41 compared to these other ones, and the control as well. The phosphorus was much higher. The calcium was much higher than the rest of them, even compared to the control pots. But I'll let Jake explain this because he did the trial. And while these are in pots, while it doesn't directly correlate to what's going on in the field, It probably does.
Okay,
Thank you. Take your clip.
There you go.
So I got introduced to Verlin when I was looking for solutions for some bottom ground. We kind of have a unique farm where half of the farm is dry land and the other half is 8 miles south and irrigated. And 10 years ago, my brother built a set of hog barns, and our irrigated ground has always outperformed the dry land. But after applying this hog manure, we're starting to see our APH increase and, you know, had those questions of why. My dream was always to come back, take over the family farm or run or be a part of it. But 1,300 acres doesn't support 2 families, let alone another brother that's interested. So the thoughts came down to, okay, we gotta grow the farm. Well, we all know that with where inputs are and where rent prices are, that's not very feasible. My first opportunity to pick up ground was $325 an acre for dryland terraces, and corn was $3.80 a bushel. So I decided I need to dive in and figure out how we can grow more with less or just be more profitable on our farm, and that's what got me into biologicals. And so our bottom ground is all commercial. The dry land now outperforms the irrigated ground by 10 to 15 bushels. And so this bottom ground's a big focus of mine. And I'm thinking, well, that hog manure's gotta have biology. Where we have tile lines, we have no problem growing 280, 290 bushel corn on top of those tile lines. I gotta figure out what that difference is. So did some testing and yeah, it's a biological factor. So then I started playing with these biologicals and started seeing some differences, but also on this bottom ground, my entire life, it's been commercial fertilizer, you know, the build, maintain, crop removal program. Our river that's next by flooded, and we were introduced to white mold. So where we were able to grow 60, 65 bushel soybeans, we're now lucky to grow 45 in the good spots. So came across, well, it was Kevin that introduced me to Verlin. So we have a water unit, didn't get a chance to run the pivot last year, which is good. But when I met Verlin, I said, I got this white mold problem, and he gave me some to trial. I wish I would have thrown the Earth Optics up because that was amazing. Sprayed a quart, Earth Optics tested, the 80 that I sprayed it on came back negative. So something in here is working. But I'm fortunate enough with my dad that's very in tune with technology and utilizing it to our benefit, you know, being able to map things, trial things, and see on the computer when everything's done, what worked, what didn't work. I continue to look for the new way of measuring. So a couple years ago, I got this Chrysolapse probe because I'm thinking that there might be a benefit if we can instantly know what's in the soil. When we pull a soil sample, it's the cost, the time, we send it in, we might get rain, we might not get rain, things change so rapidly with our variables. How do we manage our farms? So 2024, I did a biological versus no biological trial with where we put, we ran enzymes instead of a phosphorus fertilizer, ran hopper throttle on the seed, and ran Invita through on the seed as well. And so through every week to 10 days, I went out and I would probe to get a sample. And so which one here, 43? Okay. So the blue line is untreated. The nitrate level is what this probe measures. So the untreated, you can see it balancing. And a lot of times this trial just came up with more questions. You know, I have theories, but you know, added through the pivot, we could see that the untreated increased and the treated just kind of stayed. I just have a lot of theories. But what I found was interesting at the end of the year, did I really need to put that nitrate on? Because of biology, not only was there a 30 bushel difference between treated and untreated,
but we had more fertility left over, so that was kind of a sign that maybe we didn't need to put that nitrogen on.
Was this Biomentum?
No, this was before I met Berlin. We also did, well, we trialed Biomentum as a fungicide, in a fungicide trial, and this is 300, or this, in this area, this was 310 bushel corn. The phosphorus came back striking. This is now, at that time, 2 years with no application of MAP. Because I was thinking maybe we have an abundance of fertilizer, maybe nutrient tie-ups is what's causing our bottom ground to fall behind our dry land. The blue line is untreated P1 levels, the orange is untreated P2 levels, and then the gray and yellow are treated. Not gonna go through the whole thing with you, but notice with anything that was treated, so untreated P1, we started around 53 parts per million. At the end of the year, we started with 45. So we had removal. Treated P1, started with 50 parts per million, ended with 60 after 300 bushel corn. So the university, it doesn't make a whole lot of sense with crop removal. The P2, we started with 77 parts per million, ended with 90. Untreated P2 started with 80, ended with 68. So that proved to me that biologically, we do have more phosphorus than what shows up on a soil test, and we can utilize it. But during this whole trial, I was thinking, man, if there was a way that we could measure instantly what's in the plant, and last harvest, I came across an ad that said you could do it. So, James, would you say that sap sampling has you get better data through sap sampling
Absolutely,
than tissue?
because it's what's in the xylem and phloem rather than the tissue.
So this company, when I came across this company claims that this is a sap sampler. And the way both of these technologies work is there's a series of lights and it takes pictures, and each element and mineral in the soil has a different light signature, and then AI determines off those pictures what there is for nutrients. With that Chrysolabs probe, it's always been within 3% of the lab test, and most labs are within 3% of each other. So there was a leaf scanner out there, but that leaf scanner costs $15,000 a year to lease, and I didn't think that would be feasible, paying that per year, where this unit costs $2,500. You own it, you pay a subscription for the AI system, which is $750. I've already taken almost 1,000 samples with this tool, and I've only charged it once. And the data that came back was pretty striking. But I started this project because for how cheap that this thing is, can I trust it? So that's why we have these corn in pots. I figured, well, if I took potting soil, and it was the Miracle Grow all-purpose potting soil, and I think it was 0.13% nitrogen, 0.035% phosphorus, and can't remember the K. But all-purpose potting soil. So it's all the same soil, and I figured if I put an excessive amount of sulfur in one pot and grew that corn plant and scanned it, we should have an abundance of sulfur. The powder keg is a seed treatment we had left over that's got phosphorus, potassium, and silica. I should see that more than anything. The control has nothing, and then I put a splash of Biomentum in the last pot and mixed it up just to see what that does. Now this trial is only supposed to go maybe to like V6 to V8. Started taking samples at V4. And well, sulfur and nitrogen have a relationship. So the blue line in here, it showed a rapid increase, or pretty high compared to the rest of them. And then either lack of watering, during Christmas break, these plants got significantly neglected. Like 3 weeks, 2012 drought, that's why they look as beautiful as they are today. But I just found that things were interesting as the plants got taller. You know, this year is right after Christmas break where everything kind of crashed. And that control plant just stock failed, it fell over, and I figured, well, trial's over, but let's give it a shot of water and see what happens. And about 4 or 5 days later, I see that Baumentum plant. I noticed a few things after the drought stress. All 3 of the plants on the left side all sloughed off between 5 and 6 leaves, where the Baumentum plant only sloughed off 3. So that was just an interesting observation. But putting these things into charts, I noticed something that stands out, and as we go through all the nutrients, it's fascinating. You can see here at the end, by the end of this trial, our sulfur pot is the worst with total nitrogen in the plant. Baumentum is actually on the higher end of optimum for nitrogen. With the size of these plants, with the amount of nitrogen that was started, there was nothing added, so the question in my head is, where did that nitrogen come from? Phosphorus, I've got a pot where I added phosphorus to it. That pot is now in last place. Baumentum has over 100 parts per million more. No phosphorus was added. Where's that coming from? Potassium. Same thing, powdered cake. Well, second place for potassium. But also I drew trend lines in here. Notice how all these other trend lines, sulfur has a crash, that blue line. Just watch the orange line, anything that's Baumentum, except for a couple slides here, the orange line is Baumentum. So that line doesn't decrease near as fast as any of these other ones. And phosphorus, Baumentum is increasing, and it's increasing at a higher rate than the rest of these. Potassium, Baumentum is the only one that's flatlined. And as I'm taking these results and putting them into an AI system of, you know, I could spend hours, and this is where AI comes in real handy, it could be used as a tool, is if you have a way to collect data and put that data together, if you want to compare a few things, just upload the files and say, what's the difference between this? Or, you know, based off of university recommendations, you know, which plant has the best balance? And it'll do what I would do in 3 days in 30 seconds. And then you only have to spend maybe an hour verifying it. Sulfur. You know, got a pot with excessive sulfur, that plant is now dead. Baumentum has more sulfur than that pot. Calcium. Baumentum has the most calcium. Zinc. Very critical for reproductive stage. And I find that amazing how that just took off.
So do we need to add zinc in furrow to ABC?
I don't know. I just wanted to see if this tool could be used for management decisions. And so, granted, they're growing in potting soil in little tiny pots. It's going to be fun this year to see if we see the same kind of results in the field.
What do you do for a living?
Well, I help on the farm, I deal seed and play around with
Very
this.
knowledgeable. These are excellent graphs. They're just kind of curious what you actually did.
Yeah, I tried, well, I just want, I wasn't planning on presenting this, I just wanted to see, okay, this scanner, it's cheap enough compared to what the other options are, is this actually accurate, can we actually use this data to make in-field decisions? Because like
I
with
was
that.
hoping you weren't a salesman for that, that's what I was looking
No,
at.
no.
Because I mean, it looks like it works pretty well, and these are excellent information in my opinion.
Yeah. Moron, that trend line is stable, it's still a little low, so if we start seeing this in the field, this was my thoughts with this tool. You know, we might need to make a fungicide application, you can go out there and see, okay, I'm gonna get an ROI spray and, you know, putting in a quart of boron. Manganese, that's critical for grain fill. That's the only one with the trend line that goes positive. And then also with this, I was wanting to use this as a tool for nutrients. I got introduced to the redox scale and electrical conductivity, and we can make things really, really complicated with biochemistry. But EC, the electrical conductivity, I got the description there in the bottom, measuring the ability of the nutrients and ion exchange. It's basically like the heartbeat of what's going on in the plant. And the sulfur, you could tell the last sample that I took, it would be a week ago. You could tell that plant was on its way out. And it is. The rest of them are kind of barely hanging on, but this Biomentum plant's the only one that's still going. So basically all this stuff does is just give me, I have more questions. I want to be able to see this in the field, and with the theories that I have, be able to try those things. Because I also find what's interesting out of all 4 plants, the Biomentum plant's the only one that even attempted to shoot an ear.
When did you plant them?
I planted them in October.
You said you used Miracle Grow, right? Was it potting?
Yep, it was the all-purpose potting soil.
So, did you look at the label? Cause I have 20 years of greenhouse experience, and I know that that's supplemented with pine bark and peat moss and certain other amendments. Is the biometric dissolving the pine bark and you're extracting the boron and the phosphorus?
That's what my theory is, and so as soon as we're done with this presentation, I'm done with growing the plants. All the potting soil is gonna go in and get sampled as well as what we started with. Because what I'm really curious to see.
I mean, you have all that organic matter in there.
Yep.
Right? I mean, that's what they're adding to it. It drains very well. I mean, that's the idea behind potting mix or potting soil. Most homeowners overwater their plants, so they make it so it drains, so it doesn't waterlog their plants.
And that's my theory, because, just and then apply, how we apply that to the farm. The ground that we're growing phenomenal corn on, that's dry land, that's been getting hog manure, we're at 2.7% organic matter. Where the ground I'm trying to improve, that's below that, I looked at my test the other day, average of 4.8% organic matter. So I'm trying to figure out, how do I use that organic matter? And we're seeing, there's a lot of organic matter in the potting soil, and so that's where, when we send off these soil samples, I'm gonna guess that there's gonna be a lot of sulfur left in that pot. There's gonna be a lot of phosphorus, potassium, and silica left in that powder keg pot. The control, I'm gonna guess that that's gonna be mined out, and the Biomentum's gonna have more nutrients than the original potting soil. That's my theory, but, and if that proves out to be the case, then yeah, it's gonna be exciting to see what that could do in the field.
We're not.
No. But that's all I got.
How long does it take to get the results from the leaf scans?
It takes about 5 seconds to scan the leaf, and you get the results in another 3.
Which leaf do you scan?
Last
fully open leaf?
Can you scan a leaf right now to see where things are compared to your last?
Yeah, I can. I need my phone.
Live stream.
Well, I haven't seen you scan the last fully open leaf that's got the collar around it, right?
Yeah, that's the way I started, and then where the ear leaf is where I was, just like tissue sampling. So we'll
In
see.
case you didn't realize, Jake is very resourceful, very smart. And has been brought a lot of very good information to our group. And I think sending these soil samples in is gonna be very good.
He had a plot this summer that was very interesting.
We're measuring.
The plot this summer Jake had was very interesting.
Yes, it was. He had a very good test plot this summer that we, did a lot of people that.
Can taken. We now have 2,200 parts per million of nitrogen in the biomentum plant, 451 parts per million of phosphorus, 4,400 parts per million of potassium, 1,200 parts per million of calcium, 374 parts per million of sulfur, 223 parts per million of magnesium. Copper's low, iron's high, but you were saying high iron makes green leaves with grass. Pretty green plant, and it's high on iron.
Towards the grass.
Yep. 10 parts per million zinc. 0.92 parts per million of boron. 17 parts per million manganese. pH of 5.77.
You said the probe was within 3%, is that within 3% of what?
I haven't had any tissues, cause I bought this during harvest,
Gotcha.
and about 30 seconds after I got it, I was thinking, you idiot, it's gonna be next June. You.
I wasn't gonna say it.
So that's where,
So you-
well,
you
I've got
were-
access.
You know what they are now, from what he just read off, compared to when he last took them on January 21. That's the comparison.
Gotcha.
Okay.
So, it's just fun technology, and if we can get the data, I don't trust this 100% yet, because also, if you're interested, the chemistry of your leaf changes when you take a tissue test. And I don't know if you wanna share this around, I didn't print enough off for everybody. But, this Sensine company also, you know, he sent me some literature, and when you remove a leaf, the chemistry changes. And he sent me this, you know, case study, and I was like, well, I could do that in 10 minutes, you know, and verify and see what happens. So I took a leaf of the corn plant, and I just sat there and I scanned it, and I did five scans. And as soon as it made that scan, I'd hit the scan button again. And as soon as that scan, I took a scissors and I cut that leaf and then scanned that leaf that was just cut off. And it was instant. So on the sheet, if you wanna read it,
So the plant knows it's hurt.
the plant knows that it's hurt. The Brix jumps, the sugar content jumps, the conductivity jumps, nitrogen spikes, potassium spikes, calcium spikes, magnesium jumps, manganese jumps. All of these things jump, and I'm wondering, you know, what James saying, that sap sampling is a more useful.
More live versus autopsy.
Yeah, live versus autopsy is an excellent way of putting it. So it's on the back here, on the back of that page, what's biologically happening. And it's what their Sensine also came out with, but this was written by Grok. I just uploaded the results, and this is what Grok came up with. But so utilizing this new tool, you know, just like how there's a difference in how you're gonna interpret a tissue versus a sap.
Oh, my God.
For those that don't know, Grok is an AI platform, just like ChatGPT. But I think Grok is the smartest out of all of them. So even if this tool doesn't match up directly with SAP labs, directly with tissue tests, I think just the ability of, you know, starting to collect data and building, you know, building our own data set to be able to manage,
At least you're close.
to manage our crops. If it's close,
At least you're close.
That's all that
Otherwise, you have
counts.
No idea whatsoever.
yeah,
Well, and if you're taking, it's like a yield monitor, if your yield monitor is not calibrated, but your yield monitor is the same across the field, all you're looking for is a difference.
yeah,
Yes, correct, exactly. So if you're using that and you're using that all season, it doesn't
And it
necessarily
gives
have to match the lab, but it has to, as long as it's consistently the same, it's telling you whether you're deficient or not.
yeah, cause and where I was interested with having that scanner is last year, I used that probe and it said I had 10 parts per million of nitrate nitrogen left in the soil. And we were just right at tassel. And I took tissue tests and I sent them in and I was thinking, oh man, we still have, 40% of our nitrogen, to be consumed yet. So I decided, I had 90 pounds out at the time, so I'm gonna put another 45 on. I sent all that information to Verlin and I said, should I apply some more? And he goes, why would you? Well, I did it anyway, and the moment I did that is when southern rust just exploded. Because we're seeing that excessive nitrogen feeds disease. So.
Does that correlate with what you put on at the time?
Both, I think both. But that's where I'm hoping, like with this tool, when I go out there and I can see, yep, we have very little nitrate in the soil, but we got over 2,000 parts per million in the plant. I'm gonna wait.
What's that soil probe cost?
That soil probe's a little more expensive. I think it's 15,000 for a 3-year subscription, so it's 5,000 a year. But I bought it more as a dealer tool and just to instantly know what's in your soil. Because I think, when it comes to crop management, by the time you send in a soil sample, by the time you line up the co-op and everything, it might be too late, if you do need to supplement something or make a pass of something. But I'm hoping that with the results of this Biomentum, another thing that Grok has said is throughout the entire trial, Biomentum has been the most balanced plant. And I think that's what we're going for, is not how much we get into the plant, it's more of the balance of what's in the plant.
So Jake, having said that, with copper being low, molybdenum, is that? I was just saying, having said that, with molybdenum showing low and copper, and I think boron showed a little bit lower, is that necessarily a bad thing, or does that mean it's more imbalanced?
I can't confidently answer that, but that's gonna be kind of the focus this year in the field. Granted, our field soil is gonna be different than potting soil, but that's gonna be something that's always gonna be at the back of my head when I'm scanning. Okay, maybe we do a trial pass with boron and see if that translates to yield. Measure, have differences, because maybe that scanner doesn't read boron as much as a lab would. I don't know how far that's off, but it's giving me values of something. So it could be whatever our tissue test might say for boron is equal to what we would consider deficient, with what the scanner would say. So it's gonna be trials. Okay, we're low in boron, we're low in copper. We've never added copper. I don't know if there'd be much of a yield benefit with copper. But if it says we're severely deficient, maybe a pass on 3 or 5 acres to raise that, measure that, and then take that to yield. Then we'll know what to do.
They say copper helps with standability,
Yeah,
makes more elastic.
as well as with disease control. Yeah.
How much research did you do on those before you bought either of those?
They were both kind of impulse buy.
Yeah, that's what it's 3 o'clock in the morning. That one looks pretty good.
Yeah. I was like, oh, I can see where that fits in. I'm gonna try it.
Yeah.
There, so do they have, you said like from iron side, do they have baselines in that they're coming off of?
Yep, so the chart that I get, that it gives me. Oh, no.
Is that,
I didn't save that.
where are those numbers based off of? I guess is the question.
They're based off of a lab in the Netherlands, sap samples. Yeah, because that product's from France.
Did you test soybeans also? Or
No, and I talked to him yesterday. I've been pressuring them. I got them in contact with the soybean board to get a calibration started, but he's not having luck as of yesterday.
It's not,
It's only corn?
tell them about soybean.
Yeah, so right now this scanner can only scan tomatoes. They're working on olives, almonds, corn. There's a lot of garden crops.
What about wheat?
Yes, it can scan wheat.
Wheat, oats,
But I told him if this technology works as good as I think it will, or it could be as useful as I think it will, you better get a soybean calibration. Because at the same time, that ground that we demoed the Biomentum on, that ground is now 100% white mold free and grew just shy of 80 bushels an acre at 90,000 seeds dropped with no inputs. And so, but at the same time, is those plants should, when I walk through our bottom fields, we'll have beans this tall and we'll have over 250 pods on a plant. And we're thinking, we're well on our way to 100 bushel soybeans, and then go in with the combine and see 55, 60 and actually stop and look for the hole in the combine to find out half of the pods were aborted.
Yeah, open up the canopy and they're all laying on the ground.
Well, the pods aren't laying on the ground, it's all going through the combine, there's just no beans in the pods. So that's where, if I can go out there with that scanner and scan leaves and find what are we short on? Is it nitrogen, is it a micronutrient? We're short on something, because that plant was well on its way to perform to its fullest, and in a very short window, it missed something. So that's where, $2,500, if I can increase my yield by seeing something in that moment, make that impulse decision to go out and spray what it needs. But I think, like anything biologically, it's just gonna take time. We've spent 50, 60 years going with the build and maintain, fertilize, the amount of salt in our ground, the amount of, with Roundup, how much Roundup we've put on. Roundup was effective at 8 ounces with their first rake. Now we're putting on a quart. It's as much as damage as we've unintentionally caused to our soil, it's just gonna take time. But I still think that there might be ways to, help push things along. I think the Biomentum might correct it. It'd be interesting to see if there's Roundup in the potting soil. But,
We can test it.
but we can, to correct the soil, and then I really think that, our natural biology will provide everything it needs. And then it could be, and if that's not working, we might have to look into different genetics. Because a lot of our high yielding hybrids are grown on soils, just like breeding anything. If you find something that grows really well in high potassium soil, really high phosphorus soil, and you introduce that to a healthy soil that you no longer have to maintain, that high producing hybrid that was bred on that poor quality soil will no longer be fit for that high quality soil. So basically, all my research is doing is, how do I become a profitable farmer to where I can enjoy what I do and not have to worry about going bankrupt? And if we can control our weeds biologically by having our soil healthy, if we can go from traded corn to conventional corn and save that cost on the seed cost, if we can go from conventional to non-GMO and get that premium without the added inputs, and then if we can end up going organic, I'd be totally fine growing 200 bushel corn and selling it at $10 a bushel.
Jake, on your plot this year across the road, you had your soybeans and you planted varieties that were high susceptible to white mold. How'd you turn out?
No white mold at all in that plot.
What stage did you spray?
Can you all hear his question?
Uh,
Yeah. You repeat
Yeah.
his question.
So last year I had a big soybean plot where I had XtendFlex and Enlist, and it was planted in the worst spot for white mold the previous years that beans were there. Like 10 bushels is what the yield was, right where I planted this plot. And there were a lot of varieties that were in that plot that said, do not plant on white mold acres. And so with that bean program, dropped 90,000 because beans weren't supposed to make money. So I wanted to save on the seed cost, and I did a trial the year before, and 90,000 wanted. So I dropped 90,000, did a pre-pass, one post pass with just Liberty, which controlled the weeds, and then I sprayed 16 ounces of Biomentum at R4. And that's usually when white mold sets in on our field. I don't really think that I might have needed to spray at that R4 stage. But no fungicide, no insecticide, and the plot did just as good as the rest of the field. And I didn't see any white mold in that field at all this year.
So if you dropped 90,000, what was your stand count coming up?
It was 84,500.
Did you put
The
it
weed
on?
issue wasn't a problem apparently, then being that thin.
Well, we ran a very high rate of Liberty, and we sprayed it very, very late. We had Palmer Amaranth, this tall. We had 5-year-old Liberty in the back of the shed that's gone through how many freeze-thaw cycles? And I think it came out to being 60 ounces. And then I run a Nano Pro product, nanotechnology that's supposed to get 30 to 40% more of the product into the plant. I have 4 bags of AMS, 60 ounces of Liberty with the 8 ounces of that Nano Pro. I have never seen Liberty work in 3 hours.
It's kind of like syrup coming up.
And the next day, the weeds were just toast, every one of them.
They never come back.
And they didn't come back.
Yeah.
But with that high rate of Liberty, we were kind of worried about the efficacy of that Liberty. That's why we ran the high rate. It was just what was left in the tote. I probably could have hurt the bean yield by 5 bushel on that too.
Oh, yeah.
Are you in 15s or 30s?
We're on 30s.
So you had a lot of lateral branching. They branched really well.
Yes,
At 90,000 and 30s, you had a lot of side.
And I've noticed too, I think a lot of yield comes, everybody's looking at shortening their nose, but I think a lot of yield comes from the lateral branching.
Oh, yeah. No, they weren't a pencil, they were bushy,
Yep.
very bushy.
Anything else?
What did you think of the hail healing from Biomentum aminos?
Oh. All but 80 acres of our farm got smoked by hail in June or early July. And Dad was asking, oh man, our forecast looks good, we're getting a lot of rain. Maybe we should go out with a fungicide and protect, from, early diseases. Corn was at B6. And so let me call Verlin. And Verlin said, I'll just go out there with 8 ounces of Biomentum. And I was thinking, well, that's $1.50 in a sprayer pass. Is there anything that we could do to make the pass more worth it? Well, you could throw a little bit of sugar on there. Okay, well now we're up to $2 an acre. Is there anything else that we could throw out there? Because we're budgeting with this fungicide to spray 8 or 9. All said and done, we did a quart of aminos, we did Biomentum, we did and did a shot of brown sugar. And that corn plant within the next 3 days, it got that boost, and next thing we know, we had fully open leaves. And I don't think, last year was the year we should have sprayed fungicide. And we didn't, but I couldn't say that we lost any yield potential from hail damage. But we got the check.
Just on people are asking about the numbers, labs don't really have this is how much many parts per million you need for this field when it comes to tissue sampling. A lot of their numbers are kind of their educated guesses, but what they need to be at percentages of parts per million. So if you go with something like this, you need like a control baseline. Because every time you send in a tissue sample to those labs, they don't get the end yield result that goes with that sample. So they really don't have a clear, this part per million equals this many bushels. So if you do something like this, you have to have a control baseline of what your goal is and what you want to control against to see what those changes are, so that you can then make those adjustments in those areas you want to make adjustments.
Right. You can't make yield estimates based off of what your tissue is, because there's so many other different variables. We look at our soil as a gas tank. What we have in fertility and what that corn has to grow off of. And the only thing we can go off of tissue samples is if we're short on something. Do you have your image of your barrel with the most limiting nutrient? That's the only thing tissue sampling, I see the value in that is if you're short something that is short of that plant doing a natural process, going out and supplementing that, but I don't think you can't make yield
But the numbers are proving
Your
that plant.
changes aren't, like sending in a tissue sample is information. You still have to use that information as what your baseline is.
Yeah.
What your goals are. They don't, those lab numbers are an educated guess, not a, like, this many bushels of this part per million.
Yep.
Just watch like Grady Dowdy's, stuff and the research he's done with Pioneer and parts per million on a lot of the micronutrients they have are way higher than any lab can tell you.
Yeah, in most tissue labs and stuff, they'll have like a nutrient balance index where, you know, you want your nutrient balance index to be a low number. So if you've got a nutrient that's out of whack, that you're deficient in, they'll put a value to that and they'll say, well, molybdenum might be your most limiting nutrient or zinc might be your most limiting nutrient. That's what you go spray with. But what I'm hoping is instead of chasing tissue scores and chasing with a sprayer, with doing foliar sprays, I think we have these nutrients in our soil and we just need the biology to make that available. And that momentum pot, you know, especially looking at manganese and boron, which are, you know, if you follow Beck's PFR proven, you know, always apply boron and manganese with your fungicide. Well, it's in that potting soil because that plant found it. So I'd rather spend the, you know, a couple dollars investing into the soil for that soil and for those microbes to provide that to me instead of spending the $4, $6, $8 an acre on a foliar application.
The test they're doing did not have biological in their soil, was good.
Yeah.
That's why they need.
Yep. So, yeah, there's a whole bunch of different ways that you gotta look at things. Like, I could talk all day on that.
Anybody else?
So when, this is a dumb question, but, and you probably shouldn't do it, I don't know. What if you stand your arms through your hands or something? What if you
I don't know, I
stand-
haven't done it.
Okay.
But if they don't have a soybean calibration, I was kind of thinking about, looking at what the other calibrations they have and seeing which plant is closely related to soybeans. And maybe just see, you know, not make decisions off of it, but maybe just see if there's something that's related that I can use that data for.
Did you just try a soybean plant and see what showed up?
I gotta grow one.
Somebody's gotta start planting something.
Yeah.
Your calibration, that's what I'm saying, if your calibration is off of your goal, like if you have an area that's doing 80 bushel, that's your calibration, but that's your setting. You can calibrate your own numbers.
Yeah.
You don't need them to put something out there because their guess is as good as yours when it comes to your environment and what you're in. You have to have your own control, your own baseline, and try to move things that direction.
Yep.
So you can use general numbers, but your baseline is gonna entirely depend on your environment.
Right. All right, better give it back to Pearl.
Let's give Jake a hand, he did a great job. Okay, I realize we're afternoon already, but the food would be really good when we get to it. So I've got a few more things to cover here. One of them is this one right here. We've done some work with this product for the last 3 years. And you can see in your packet what's in it. It's sulfur, iron, copper, moly, zinc, manganese, boron, and there's also carbon in there. The reason those are in there because and amino acids, excuse me. And we've already covered the importance of all 3 of those in here. But this is, we've got a guy in North Dakota been using this for 2 years, so we tried it this year. Have a guy, 32 ounces of Biomentum, he got 190 bushel. When he put 16 ounces of biology and 16 ounces of this, he picked up 9 bushel. Again, the fungicide came through, gave him another 5. on another trial, different field, different corn, 157 with just cord biomentum. When he put the two together, he picked up 18 bushel, he went to 175. So this variety was very responsive for whatever reason to the nutrients. And then, of course, the fungicide picked them up another 6 bushel. This is something that you guys need to be aware of. If we're talking about iron and the importance of chlorophyll and how that makes a difference in sugar. How many of you had rust or tar spot this year on your corn? It's pretty universal, wasn't it? So when you get the sun's radiation during these critical times, R1, R2 to grain fill, in 23, the radiation was going up during those time periods. 24, same way. This past year, it kind of horsed around and then it went into the dumper. It takes that sun's radiation in order to make sugar. It doesn't just take carbon dioxide and water, it takes the sun's sunlight. And if you don't have enough iron there, you're not gonna get chlorophyll, and that's not gonna happen either. So the reason I put this up here is, I realize we can't do anything about this, but you know, this all took place about the time the southern rust and the tar spot was moving in. When we got a decrease in this. So what's happening during that time? The plant is not making as much sugar. The sugar is the lifeblood of that plant. When you do not have enough sugar, the immune system gets compromised as well because that plant is trying to stay alive. Okay? So I think that impacted the severity of what we had this past year, not only because it kept blowing up here every 2 days the way it seemed, but when that plant is in that condition with low sunlight, and I fully believe this is why this stuff worked on these particular fields as well as it did at these lower rates, because we got some of those nutrients in there, we got carbon in there, we got amino acids in there, which are the basis of nitrogen in the first place. So we're gonna be doing more testing with it this year. So I just wanted to throw that at you. This is just a little explanation of iron, how it produces chlorophyll. You guys always wanna see numbers, they're in your packets. This guy, Conklin guy, and he put the biomentum with his fertilizer, picked up some bushels. Same way over here, same way over here. Again, he has the nutrients with it. There's some sulfur in there and there's some other things. This was the trial up in South Dakota. We talked about, you know, the effect of different things on reducing biological counts. This is bifenthrin, and this guy with, this first year, bifenthrin, ABC with bifenthrin, got 222, and 224, and without 224 and 232. This was run against Relay, that's Lula and Dowdy's product. 213, 219 with the ABC. Another one with Relay, 230, 235. ABC against Start Right, that's another one of their products there, and you can see the numbers on the side there. This was also a soybean trial where he did with and without in furrow. That's just an explanation of another one here where they put 16 ounces of biomentum on. Post herbicide at V3, picked up 8 bushel on soybeans. This is, we talked about, this gentleman over here talked about breaking down the organic matter in those pods. So this comes from James, he took a picture here this summer. This is corn residue from the year before, where nothing was put on. This is same with put on. Does it break down?
Lots of biomentum on that field.
How much?
80 ounces through the whole season.
Okay, 80 ounces of biomentum throughout the whole season, nothing in furrow, just over the top, right? Okay, so, that's a lot of difference in, nutrients that we were talking about, again, soybeans without, with. And this just gives you a chart of telling you what, nutrients are in there, just the N, P, and K, and sulfur. There's a lot more than that, actually. And this is just for your own, um, um, information, again, economics of getting that broke down. 200 bushel corn gives you a ton of residue per 40 bushel of corn. Nitrogen, phosphorus, potassium, all adds up to that. You take that number times 5, and that's $125 dollars per acre of nutrients. If you get that residue broken down, the residue digester costs $8.65 an acre. Is that a no-brainer or not? Because the nutrients broken down from plant residue is what the crop wants first, and it will always take that out. If you can break that down over the growing season, you're getting that advantage. A lot of different, theories on how to break it down. Iowa State University did a 3-year test, and they found out that tillage, traits, and nitrogen don't affect corn residue breakdown. They found out it's all due to fungal activity. Soil compaction, and again, we're not gonna go into that. Hopefully I made my point, on that, but this is no lie, 10 to 50%. I had a customer about 4 or 5 years ago, where he started using biology. He called me up one night and he said, I've got this combine, he said, my corn monitor's going from 150 to 250. What's going on out here? So I went out the next morning with that penetrometer, and where it was 150, that's how far you could get that thing in the ground in your paper. Where he was getting 250, you could go down this far. If you don't think compaction is costing you money, think again. Everybody's got a compaction layer wherever your last tillage pass was, whatever that was, I'll guarantee you that's where your compaction layer is gonna be. Okay, with that, we have some sheets we want to hand out. We're gonna, and then we'll have lunch. We'll briefly go over these. And these are the recommendations, what we're recommending for a program this coming year. And there's also, everybody wants to know, well, what's this stuff gonna cost me? So we've got also the price sheets in there with it. And we'll give you, and all of you get those. We'll go through those so you can see what we're looking at.
How long will compaction speed around if you got there, it's no till?
Say that again, Ron.
With the compaction there and you no tilling for 15, 20 years, still be there?
Oh, yeah. Yep. Is that the biological?
Yeah.
No, okay, so the question was, so if you're been no-tilling for 10, 15, 20 years, and you got a compaction layer this far down, is that still there? So I want to go back to this one thing. The presenters last Friday out there in Illinois all said the same thing. If you don't have oxygen in your soil, you are going to have compaction. You do not have structure because you lack the aerobic biology that it requires to do that. And so I want to go back to the illustration of what we do in the manure pits. And that the fact that the biology is facultative. So when you put this in furrow, this same guy that I was referring to that had 100 bushel difference in yield on these different spots. A year later, he rented a piece of ground and he had a hard time getting the planter in the ground. So I said, okay, so we started putting the ABC in furrow. And you could go down with that thing about that far and you'd stop it with that penetrometer. After about a month, we were down about this far. And by the end of the season, we were down this far. The reason that happens biologically is because the anaerobic biology is going to work in those zones where it's compacted. That's a toxic zone, the pH is very low, roots will not go through that. And when it goes through that, then the aerobic takes over and it keeps on working down. Now, if you have severe compaction, and you have to remember that the biology is systemic. We spray it on the plant, it goes through the plant down into the root system. So if the roots are this deep, it'll go that far down. If you spray it again in about a month, it'll go down that far if the roots are down further. So you're building that whole system. There's two ways to do that. And you can speed it up when you spray it on foliarly as well. That answer your question?
Yeah, it's a,
Okay.
Do worms and night crawlers accomplish the same thing?
Do worms and night crawlers accomplish the same thing? Absolutely. You go out in Dwight's field and you got a hard time not stepping on night crawlers, don't you, Dwight? He's got earthworm casting holes. It looks like a top of a pepper and salt shaker. There's holes everywhere. And of course, they aerate your soil. And they always say that worms are at the top of the food chain. So when you have earthworms, you have that whole cycle in your soil. We have one heck of a time getting anything done foliarly or in furrow at Dwight's farm because of all the biological activity going, don't we? We never see anything, no matter what we do. But you get that biological activity going and it's very difficult to get up. And I hear that from guys all the time. The more your soil is fixed, so to speak, the less you're gonna see with foliar applications and all of that. I hear that from customers. Has everybody gotten the sheets? Okay, I better come on. Okay, we'll take a look at these and then we'll break for lunch and then you guys can go on your merry way. So there's two sheets there, suggested retail pricing. The one I want you to get out is Terra Transitional Solutions, and we'll briefly go over that. These are suggestions from what we've been talking about as far as the products and how they've been used and what we're seeing, so we're giving our best estimates. Fall residue digestion, corn or beans, fall or spring. What you saw up here was during the year. A lot of people use our fall digester. It doesn't matter, that stuff can freeze and thaw and it takes right up in the spring. But the rate on the fall digester is 64 ounces, 2 quarts. We just put a 100-acre deal in there so you can do easy figuring if you want to do that. We left slots in there, so if you want to do it on your own field, you can figure out yourself what it's costing you. The digester, as you can see, is $17.43 a gallon, so it'd be $8.72 an acre. If you did 100 acres, that'd be 50 gallons or $871. If you go down to the planting, corn and soybeans, again, ABC and furrow. For anybody that can do that, we strongly recommend it. It's the basis of our program. 3 quarts per acre, $15 a gallon, 11 1/4 a gallon. I hope you see the value with what Jake showed here and some of the other stuff, that nutrient availability is a big deal. And I really hope you guys think about doing tissue testing. Sap testing is the best. Then if you go to corn and beans, at V3 to V5 and at R1 is on the left-hand corner there. There's actually 2 options listed there. Biomentum at 16 ounces or the ABC at 32 ounces. We have a guy new customer down in Kansas, just into Kansas this past year. We got all these producers that come up with all these ideas. He put the ABC in furrow on his soybeans. He came back at V3 and at R1 with 32 ounces of ABC. He called about a month ago and told the distributor, my neighbors all had 65 bushel beans. My beans were average 85 to 90 bushel a year. He gave carbon and he gave it the nitrogen, the amino acids in a form that the soybean plant did not have to do anything to change into amino acids. The biggest thing the plant does during its whole cycle is make amino acids. Okay? So just saying. So that's why we put that in there as an option. The Biomentum at 16 ounces is $3 and the ABC is $3.75. So the leaf disease issues, corn and soybeans, Biomentum at 16 ounces, we're not guaranteeing anything, especially when we have a year like last year, the year before. We had some pretty good luck with the Biomentum against southern rust, but Biomentum is not a side. It's not a fungicide. It's not a herbicide. It's none of those. What it's going to do, if it's going to do anything, it's going to make nutrients available in the plant. And nutrition, I think, is one of the key things to fighting off some of these diseases in lieu of using a fungicide. But again, we're not saying don't use a fungicide.
Verlin, there's fulvic in the foliar pack, right?
There is, in the foliar pack that I showed you up there, there's amino acids, there's some sugar, there's trace minerals, as you can see on the label, and there's fulvic acid. All very important.
How many gallons an acre do you put on? I assume you mix it with water.
We're mixing it with water, anywhere from 10 to 20 gallons per acre. We haven't had anybody put it through a pivot, so I don't know if that's effective or not. So again, down there, leaf diseases, either Biomentum or the foliar pack or the combination actually. We're seeing some pretty good results on that. We're going to be doing some testing with some new products this year that I've been told by the people that own the company. They have used them all over the world and they will take care of tar spot and southern rust and all that kind of stuff. So, but I'm the one you know me, I want to see the numbers. So we'll wait until we get that. And next year at this time, hopefully we'll have something that can effectively replace fungicides, which just are terribly hard on what we're trying to produce in the soil, the fungicide of everything. So,
Don't spray.
anybody have any questions on this sheet? Yeah. It's pretty simple, self-explanatory. You can put the ABC with any starter, it doesn't matter if that's your program. We're not telling you to go away from starters, depends on your soil test, your fertility of your soil, but we've got a lot of guys, if their fertility in their soil is good, they're not gonna put any starter fertilizer on this year. And that's their decision. No. Okay. All right. Again, you have the price sheets there. I hope you can see with what we're trying to do biologically as a company, some ways which it may help to lower the input costs and improve your bottom line. Because with what we've done so far, we've had very little negative feedback. We have had some. Russ has had some issues with white mold that he's not been able to get ahead of with just the Biomentum. So there's nothing 100%, but yes, go ahead.
I think it's in timing more than,
Pardon me?
I think it's in timing.
Russ just said, I think it's timing, and, you know, that's that way with everything, that we do in agriculture today. We had guys last year that had white mold in their fields, they saw it, two different guys, and they went in there with a biomental, and they stopped cold. I don't wanna get that reputation. We're not a Band-Aid company. Mention company, hopefully. John,
Don't wait till it's there.
don't wait till it's there. So what's a good time, John?
Because if it's flowering and conditions are there, that's how white mold can start. But it gets in through a flower or a wound of any kind. So if it's flowering and you got time, go put it out there. It's a great preventative.
It is.
And it's not a side, like you said, but I have seen its diseases stop after an application.
I know, I don't wanna be a Band-Aid company though, so. Hopefully this gives you some ideas on your spring planting needs, on what we recommend as a company. And we invite any other questions, comments, good or bad, it's okay.
I'm not gonna stand in the way of lunch.
Pardon me?
I'm not gonna be standing in the way of lunch for everybody.
We'll be here after lunch, but let's have a word of prayer before we have lunch. God and Heavenly Father, we just thank you for this time again today, and we just ask a blessing on this food which we're about to eat, so that we may all continue to serve you each in our own way, especially all the people that are here today that are striving to produce food for all of us to eat. And so we just ask for safe travel as everybody journeys home again today. We pray this all in your name. Amen. Thank you all for coming.
Say it again.